Good morning to all of you. Welcome back in the third session of file management of operating system. So already we have learned about file management, the organization of a file, structure of a file, elements of that particular file. Now we are going to learn about two-level scheme for a directory. So one directory for each user and a master directory. These are the two levels. Master directory contains entry for each user, provides address and access control information. Then, each user directory is a simple list of files for that user. Still provides no help in structuring collection of files. Then, hierarchical or tree structure directory. Master directory with user directories underneath it is a hierarchical, or we can say that tree structure directory. Each user directory may have subdirectories and files as entries. So the diagram represents the structure of a tree structured directory. It has a master directory, then subdirectories are there, and after that file entries are there. At the root of this directory there is a master directory, and at the leaf nodes of this tree structure directory there are the files. The structure is like a tree, so that the name is given as a tree structure tree directory. Then example of tree structure directory, real one. There is a master directory, that is a system, user A, B, C. Then directory, various directories are there, subdirectories we can say that, user C, user A, and at last there will be the files which will act as entries. This is about the example of structure directory. Then files can be located by following a path from the root or master directory down various branches. This is the path name for the file. It can have several files with the same file name as long as they have unique path names. So, hierarchical or tree structure directory can be located from the root, master, or directory down various branches. Current directory is the working directory. Files are referenced relative to the working directory. Then next one is a file sharing. So in multi-user system, it allows files to be shared among users. But while sharing, there are two issues. First one is access rights and management of simultaneous access. So to whom we can give the access rights? Because whenever we consider a security concern, so we must have access rights. Means we must have to give access rights to that particular directory. Then management of simultaneous access. So access rights none. User may not know of the existence of the file, or user is not allowed to read the user directory that includes the file. This is a none access right. In knowledge, user can only determine that the file exists and who its owner is. Execution. The user can load and execute a program but cannot copy it. Then reading. User can read the file for any purpose, including copying and execution. Then appending. The user can add data to the file but cannot modify or delete any of the file's contents. Then updating. The user can modify, delete and add to the file's data. This includes creating the file, rewriting it, and removing all or part of the data. Then changing protection. User can change access rights granted to other users. Then deletion. User can delete the file. Then owners. As all rights previously listed, Grant rights to others. We grant rights to others using the following class of users, that is specific user, user groups, all the public files. Then simultaneous access. So user may lock entire file when it is to be updated. User may lock the individual records during the update. Then mutual exclusion and deadlock are issues for shared access. So here is the fixed blocking. So there are the squares which represent a particular thing. This faint blue colored square represents data. The gray color represents gaps due to hardware design. Then lines, rectangle with lines. We can say that left side lines, west due to block feed to track size. And lines to right, west due to record feed to block size. Then last one, lines at the both sides, west due to block size constraint from fixed record size. So this is a fixed blocking. R1, R2, R3, R4, R5, R6, R7, R8 are data. Track 1, track 2. So variable blocking spanned. Here in this variable blocking spanned, two of any blocks are same, which are given same name but may have different block size. Then unspanned. So in this there isn't any same name of the field exist, but the blocks which are given, so for example with base due to block feed to track size is different in both the tracks, or we can say that base due to record feed to block size are of different sizes. Then secondary storage management. Space must be allocated to files, must keep track of the space available for allocation. Pre-allocation means need the maximum size for the file at the time of creation. So previously allocating things, difficult to reliably estimate the maximum potential size of the file. We tend to overestimate file size so as not to run out of space. Then contiguous allocation. Single set of blocks is allocated to a file at the time of creation. Only a single entry in the file allocation table, starting block and length of the file. Then external fragmentation will occur. Need to perform compaction. So this is about contiguous allocation. So the diagram represents contiguous file allocation table. File name, start block, length. File A, B, C, D, E. Depending upon the name, the particular rectangle shows a particular file. Then contiguous file allocation after compaction. Do compaction and then allocate files. Then chained allocation. Allocation on the basis of individual block. Each block contains a pointer to the next block in the chain. Only single entry in the file allocation table. Starting block and length of the file. No external fragmentation is there, best for sequential files. No accommodation of the principle of locality. So the diagram represents a chained allocation. One block is related with another block by using a chain like a structure. After consolidation, there is also chained allocation. Then indexed allocation. File allocation table contains a separate one level index for each file. The index has one entry for each portion allocated to the file. File allocation table contains block number for the index. So this is about index.